matrix and determinant. Before this one videos, I solved some questions related to function. I already told you can solve the rest of the questions. If any queries, and you can directly contact me. But now see matrix. What is matrix? Matrix is a simple arrangement of number, element, object, anything which can be written in the form of a row and column, row wise and column wise. The arrangement of the number, element, or any goods which can arrange in the row wise and column wise like this way. And some of the elements are arranging like in this manner, either row wise or in column wise, like this way. And this arrangement is known as matrix. For example, suppose in school time, the assembly, the arranging of the assembly, always the students are standing in the row, like this is class 6, this is class 7, this is class 8, like this manner. And these are these arrangement of the students for the prayer ground. Suppose this is class 6, 7, 8, 9, 10, 11, and like this way, this is 12. Means this is the arrangement of in a rectangular field. In a rectangular arrangement is known as matrix. The same manner, see, A is denoted the matrix, and all these elements A1, A11, A12, A13, A14, A1n means these are represented rows, and these horizontal arrangement is known as row, and the vertical lines is known as column. A11, and some students are reading these things A11, A12. This is incorrect. Correct is that A11. A11 means first row, first element. A12, first row, second element. A13, first row, third element. Like the same manner, A1n, first row, nth element. And come to the second row, first element, second row, second element, second row, third element, and the same way, second row, nth element. And this is known as the first row, this is second row, third row, fourth row, like the same manner. And then lastly, the AM1 means mth row, like the same one, 1, 2, 3, 4, 5, and same way. And it will come the mth row, first element, mth row, second element, mth row, third element, mth row, fourth element, the same manner, because we have m row and n column. M rows means m rows, and n are the column. So the last element will come AMN means mnth, and this is known as the order m cross n. This is the order of this matrix, and these are known as rows, and these are known as column. I have written here also. And now see the element is similar element of this. This is known as the principal diagonal. This is known as principal diagonal. This is known as principal diagonal. A11, A12, A13, A11, A22, A23, A33, A44, A55, like the same manner. This is known as principal diagonal. And these all elements A11, A12, A13 are known as the elements, and whole of these things is known as matrix. This is a simple arrangement of elements, numbers, goods, or anything which can be written in the form of row wise and column wise is known as matrix. Now see type of matrix. Matrix, the type of matrix. Number 1. A row matrix. Row matrix. I have written here matrics. Matrices means this is the plural form of the matrix. And I have written here row matrix. This is only one single matrix. So matrix. Row matrix means a matrix A and having only one row and so many columns. 1, 2, 3, 4 suppose. This is only a matrix having one row means 1, cross 4 columns, 1, 2, 3, 4, 4 columns, and can be written 1 cross 4. Number 2, column matrix. Column matrix. A matrix having one column, 1, 2, 3, 4, like this way. And the order can be written m cross n, 1, 2, 3, 4. 4 row cross column. It means a row cross column. It means row is 4 cross 1. Row matrix, column matrix. Number 3, square matrix. Square matrix is a matrix in which number of row and number of column both are same is known as square matrix. Suppose 1, 2, 3, 4, 5, 6, 7, 8, 9 having 3 rows and 3 columns, so its order can be written 3 cross 3. This is really very important. Square matrix is very important in whole matrix. Having the number of row as well as number of column both are same is known as square matrix. Number 4, null matrix. Null matrix is a matrix. Null matrix is not a square matrix. It may be a square matrix or other matrix also. If all the elements, now see, all the elements of any matrix are 0 zeros, means all elements of the matrix are zeros, is known as null matrix. It may be, now see, this order is 2 cross 3 or 0 0 0 0 0 0, means I am writing here the matrix having the order is 3 cross 3, and this is known as also null matrix. Fifth one, identity matrix. Identity matrix or unit matrix. Is denoted by I. If its principal diagonal is 1 1 1 and the rest of the elements are 0, and it should be also a square matrix. A square matrix having the principal diagonals, elements of the principal diagonal is 1 and the rest of the elements are 0, like 1 0 0, 0 1 0, 0 0 1, and this is 3 cross 3, or it may be, and it is also denoted by, because this is 3 cross 3, I3 can be written also, and suppose I am writing here I2 means 2 cross 2, 1 0 0 1, and this is 2 cross 2 is also identity or unit matrix. Next one, I am rubbing this one. Next one is a scalar matrix. A scalar matrix is a matrix. This is just like a unit matrix, but in place of the principal diagonal elements are 1 1 1. In scalar matrix, the principal diagonal elements are other than 1. And a square matrix, this can be written in the form of either 2 0 0, 0 2 0, 0 0 2. This is also a square matrix having the principal diagonals are other than 1, but all are same elements, is known as scalar matrix. Number 7 is diagonal matrix. Diagonal matrix. Diagonal matrix means a matrix. This is also a square matrix having the principal diagonal is non-zero element, like 1 0 0, 0 2 0, 0 0 3, and this is also a square matrix. A square matrix whose principal diagonal is non-zero element and the rest of the elements are 0 is known as diagonal matrix. Number 8. Number 8 is triangular matrix. triangular matrix, there is two types of matrix. Number one, number two. Upper triangular matrix. Upper triangular matrix. And number two, lower triangular matrix. And for the upper triangular matrix, upper triangular matrix, upper triangular matrix is a matrix in which above the principal diagonal, all elements are non-zero, and the lower of the principal diagonals elements are zeros, is known as upper triangular matrix, like 1 2 3 0 4 5 0 0 7, and this is 3 cross 3, and this is the principal diagonal, and above the principal diagonal means all elements. Now this all elements above the principal diagonals are non-zero. When we will join these elements and we will get a triangle, we will get a upper triangle. Now see, after joining these elements we are getting a triangle, and this is known as upper triangular matrix. And number two is lower triangular matrix. Lower triangular matrix is a matrix in which the below the principal diagonals are non-zero and above the principal diagonals are zero element, like 1 0 0 2 5 0 0 0 3 6 7. This is also a square matrix. Below the principal diagonals, all elements are non-zero. By joining these elements we will get a triangle, but below the principal diagonal, now see, we have a triangle and below the principal diagonal, and this is known as lower triangular matrix, this is known as upper triangular matrix. And I am learning this one things also, and some more triangle matrix are there in our course. Now see, now next is symmetric and skew-symmetric matrix. What do we mean by the symmetric and skew-symmetric matrix? If a matrix, before this symmetric and skew-symmetric matrix, I would like to start. Okay. Now see, next matrix, this is transposer matrix. Transposer matrix means a matrix A equal to 1 2 3 4 5 6 7 8 9. And transposer matrix means if row are converted into the column and column is converted into the row, is known as transposer matrix, like this way. 1 2 3 is the first row, and we have to change this 1 2 3 like this way. 1 2 3, the row is converted into the column, and second row becomes the second column. 4 5 6, and we have to write this one thing 4 5 6, and 7 8 9 is the third row, and we have to write these things in 7 8 9 in column, and represented by 80. A and 80. This is known as the transposer matrix. Okay. Now, after that we come to the symmetric and skew-symmetric matrix. Symmetric matrix. First of all, we will study symmetric matrix. Symmetric matrix. Symmetric matrix means in which a matrix in which the condition is this: A equal to 80 means a matrix is just equal to its transposer matrix. By transformation of any matrix, and the matrix they having no changing at all is known as transposer matrix, in which one example is there, and in which the elements will lie in such a manner Aij equal to Aji. And what do you mean by the Aij equal to Aji? Just I will tell you after 1 minute. Now see, suppose a matrix is A. I am writing here 1 2 3 and 2 4 5, then 3 5 7, and this is a matrix of order 3 cross 3. I have written these things now. Here this is known as, this is the first element, this is known as 1 is equal to, this is A11, A11 means Aij, and this is A12, and second is A12. I already told you before starting this one means a main in which I have started A11. This is A12, A13, A21, A22, A23, and here if A12 and A21 both are same. Now see, this is A12 in which A12 and A21 both are same. A22 equal to A22, A23 equal to A32, like this way. A11 is same way. In its principal diagonal are these elements, and the rest, this is A12, this element and this element must be same. Means this is A12 and this is A21. A12 equal to A21. I have written Aij equal to Aji. Means A12 and A21 both are same. A13 and A31 both are same. A23 and A32 both are same. Then by transpose of these matrices, now see, by transformation of this matrix AT, and we will get a row is converted into column 1, 2, 3, and we have to write these things 1, 2, 3, and the second row is converted into the second column 2, 4, 5, and third row is converted to the third column 3, 5, 7, and this is 3 cross 3. Now we can check both of them. Both the matrices are same. Now see 1, 2, 3, 1, 2, 3, 2, 4, 5, 2, 4, 5, 3, 5, 7, 3, 5, 7. No changing at all. It means A equal to AT, and which is known as symmetric matrix. If transpose of the row and column, there is no changing at all, in which Aij equal to Aji, means A21 equal to A12, A32 equal to A23, like this way. By changing these things, we will get no changing at all. This is known as symmetric matrix. Now come to the next one, is symmetric matrix. Symmetric matrix. Symmetric matrix in which A equal to minus AT and Aij equal to minus Aji. This is main things. Aij equal to minus Aji. Like A is a matrix, or in which in symmetric matrix, keep in mind, in symmetric matrix, its principal diagonal elements will come 0, 0, 0. Now see, this is 0, suppose this is 2, 4, and this is 2, it means just here, this is A12, A21 will come 2, but negative sign, and its principal diagonal is 0, and suppose here 3, and then this is 4, and this will become minus 4, and this is 2, 3, and this is 2, 3, 2 will come minus 3, and this is 0. Because I already told you, and for the symmetric matrix, its principal diagonal will come 0, 0, and the rest of the elements will arrange in such a manner that Aij is equal to minus Aji, and first row second element, and second row first element same but sign will oppose, and the first row third element, and here third row first element will same but opposite in sign. Like the same way, second row third element, this is third row second element, both are same but opposite in sign. When we will do transpose, now see, a row is converted into column 0 to 4, minus 2, 0, 3, and minus 4, minus 3, 0 will come. So AT is equal to, if we will take minus is common from this one, then in place of minus it will become positive, and in place of positive it will become negative. Now see, 0, 2, 4, minus 2, 0, 3 will come, and then minus 4, minus 3, 0 will come, and this is also known as this one matrix A. So AT equal to minus A, or A equal to minus AT. This is the property of the symmetric matrix. Till here, all the types of matrix you have to go through it and learn these matrix types of matrix. After that you can understand better way, and just after that I will solve some questions in the next video, and we will start how to construct the matrix, construction of the matrix, and after that we will start some questions related to your NCERT books. Okay, thank you.